So I'm going to do just one of these, that we'll look at the answers for the other. Then we'll check your homework from, well, it was kind of classwork homework from yesterday. Okay, so again, when it says solve a triangle, it means find, at the end, you should have all 6 pieces defined. And so 3 angles, 3 side lengths. Cool, thank you. What's a good place to start on 24? Okay. Yeah, and so, on numbers 1 through 9 in yesterday's work, it asked you to find angles using trig, because that was the only way. Let me just pull that up. It'll be a little bit of scrolling, and we'll look at the difference. So I'm just picking a random number, like number 4. So that one has a theta and a 90. So why do we have to use trig to solve those ones, the number 1 through 9, or 1 through 8 maybe?
If you don't know what it means or what it is.
Yeah, I mean, that's exactly right. We have only one known angle, and that would make 2 variables. Whereas down here, we have 2 known angles, and I'm telling you this because, like, when you do your test next week, I'm not going to say solve for the angle using trig. I will say solve for the variables, or solve the triangle, even like these say. So it's helpful to note the shortcuts. Like in this one, hey, I have 2 angles. I can just do what to find the third one in this case?
90 minus 20.
Yeah, just subtract, right? We don't have to get into all that trig. And so measure of angle A is just, and I like how you said 90 minus the known angle. We don't have to involve the 180. Why not?
Because the other angle will make up 90, and 90 plus 90 is just 180. So.
Yeah, good. So measure of angle A is 62. Yeah, exactly. So because we have a 90, the other 2 are complementary. It just saves a little bit of work. All right. Now we don't have the side lengths. We have no way to solve for them other than trig. What would be our other 2 options if we could, potentially? Like, what are you checking for? In terms of solving for sides, we talked about this yesterday. Pythagorean theorem, because it's a right triangle, and special, good job, special right triangles. So this, in this case, definitely isn't a special right triangle, but it's close, isn't it? Right? So I want you to, because it's close, because this is close to 30, if it was 30, what would AC be?
63.
It would be 3, right? It's, no, sorry. This is not the hypotenuse. So 6 divided by root 3. So 6 root 3 over 3. So 2 root 3. Okay? So roughly, if this was a 30, 60, 90, 2 root 3 is like 3.4 or so. Okay? So it's going to be a little bit smaller than that. Let's go do that. What trig ratio should we use to solve? And just to make the notation easier, let's call AC, we'll call X, and AB we'll call Y. Which trig ratio relates X and our other known information? Those, in other words. Okay. Yeah. And so I hear some of you saying this, so good job. This is opposite and this is adjacent. So that's OA in SOHCAHTOA. Do you remember SOHCAHTOA? Yeah?
Yeah, that's right now.
SOHCAHTOA, get it? SOHCAHTOA. All right, SOHCAHTOA. Anyway.
We just got it.
Yeah. TOA. So TOA, is tangent. So we'll say tangent of 28. You know what? Just to stay consistent with what we've been doing, tangent of B is opposite over adjacent. That way we have something to fill in. So tangent of 28 is x over 6. How do we get x by itself? Yep, times 6. And then the whole left side now can just go in your calculator. What do you need to make sure before you punch numbers? Because remember, mine resets every day. Yeah. So let me go fix that. Degrees. And we'll do, sorry, I forgot what it was, 6 tangent of 28. And we get 3.19. Do you remember what we said it should be close to? Yep. See how you can use these things to kind of give little checks on your work, right? Like, hey, if that is really close to 30, 60, 90, it would be 3.4 or so. All right, good. And then now we have options to solve for y, which are what? Pythagorean theorem, if you would like. Or we can do another trig ratio. Because we're currently doing trig ratios, I'm going to use that one. So now we're relating, oh, by the way, word of advice, when you go to solve for another unknown, my suggestion is try not to use other things you've solved for. Because if you did make a mistake, it just now carries that through. We can solve for y with only given information, and then we're at least starting from accurate information. So what relates y, 6, and 28? That's cosine this time, right? So cosine of b is adjacent over hypotenuse. I feel like you guys are getting the setup, the trig ratio setup really well. So good job on that. 6 over y. And this is slightly different. How do we get that y out of the denominator? Yeah, just multiply by it. And then we'll get y cosine 28. Cosine 28 is just a number, so we'll divide by it. And we'll get 6 over cosine 28. 6.8. We'll round to the nearest tenth there. So 6.8. All right, we have 3 known side lengths and 3 known angles. So the triangle is considered solved. Any questions on that one? All right, let's check number 23. And there's those answers. How'd it go? Okay. Let's check your homework, and then I want to, before we move to the next topic, I want to check in with you on these. So your homework, classwork homework was 1 through 8, and is that big enough? Can you guys see all the red numbers? Okay, so I'll give you a second to check your work. Well, check your answers, and then we can do any if you have trouble on them. How many of you remembered to label degrees, the little degree symbol? Do that. In terms of grading, let's say I grade your test and I'm seeing a trend of no degree symbols. The way I usually grade that is take off points maybe once or twice. I'm not going to ding you the whole test, okay? But do get in the habit of putting degrees on there because it's not the same as radians. So, if we have 2 ways to measure angles. Any of these we need to go do, to prove that the answer is what it is? Okay, hold up how many you got right out of 8 on just that section, please. She's just rocking it, that's why. Okay. All right, that's good. Averaging probably a 7 out of 8. So I'm going to use that as our check on angle solving. And then can you please just do a fist of 5 on side length solving, kind of like what we did in 23 and 24, so fist of 5 just on side length solving with trig specifically. Lyra, just waiting on yours. Fist of 5 on side length solving. No, we already did. Like, we did those two in our warm-up. We had to side length solve, and then the day before we did 9 through 16. Okay, you're good. What was yours? Okay, so we're averaging just under a 4, so good. And if you're just under a 4, the next work is going to build on this. You'll get more practice. It's not like we're just stepping off of it. We're just going to take it to application now. And guys, I'm kind of excited about this. It's cool, the way that we use this stuff. So grab your notes. I need to give you a few of those before we start. We're going to have 2 sections in this unit today and then probably Monday, where we take what we've learned and apply it into actual measurement kind of context out in the real world. Next week, test I have scheduled for Wednesday. Thursday or Friday, we'll go outside again and use this stuff now to the trig stuff to measure and compare methods. Okay? Did you say burr?
Yes.
I know, it's definitely colder now. Maybe we'll get a good sunny day. Anyway, it'll be fun. Mr. Pism, while you're here, I have a question. To do that, we need to use an app on a phone called a clinometer. Just is that okay? Okay. We'll be outside. Yeah, we can. I yes. Maybe we'll do that. That's a good idea. The protractor version. I have string. We just need some heavy weight, like just weighted objects. Yeah. We'll hit up the tech ed group. That would be kind of fun to make them. All right, so what we're talking about right now is in context trig ratios. We're going to have a section, like I said, another section that's in context, but it will be law of sines and law of cosines. So make sure that you're not getting those mixed up. Okay, first thing is angle of elevation. So we'll define it. I'll give you a picture. It will definitely help clear this up. So the angle of elevation is the angle formed by the horizontal. And I want you to underline that word because the more you get in the habit of saying with the horizontal, the better, because depression, which is next, is going to be a little more confusing. So it's the angle formed by the horizontal and the line of sight. That's not sight. Spelled it wrong. Line of sight. There we go. And then let's go ahead and define angle of depression. Kind of a funny name. By the way, before we do that, I forgot to keep adding to angle of elevation. The angle formed by the horizontal and the line of sight up to, underline that, the object. Elevation, think of something being higher or above. So we're looking up. Okay, and then I bet you can guess angle of depression is what? Say that again. Yeah, looking down. But this is the one that students mess up on. And we'll get into why here in just a bit, but definitely this one, make sure you say with the horizontal or by the horizontal. Okay, so the horizontal and line of sight. And now we're looking down. Whatever we're looking at, like that's going to change. So I left these little boxes up here blank so that we can go draw the picture. And I think that will help clear this up. What do you want to look up at? You know what? I'm just going to give you one because this is kind of a typical. So draw, I don't know, I'm not a very good artist, but do your best to draw like a hot air balloon. And then somebody down on the ground. They are looking at each other. So we're going to draw a line of sight between them. And just do that kind of dashed. Okay. Can you see the line of sight? When we're outside looking at stuff, can you see the line of sight? You're good?
All right. Lyra, Isla, and Corbin.
Corbin's absent.
Okay.
Thank you.
Thank you.
Okay, so think about when we were outside on the tennis court and we were looking up at the top of the light pole. Is there a line there that we're actually seeing? No. And so that's why I had you do it like in a dashed form. Okay, so these two are looking up at each other, looking up and down. So the angle of depression, again, we said was with the horizontal. So it is also an imaginary line. And then the person looking up, also with the horizontal. What kind of angles are those? Those are alternate interior angles. In other words, the people in the hot air balloon and the person on the ground, they're looking at each other with the same angle relative to the horizontal. And so you might be able to use that to your advantage when you start solving some of these, okay? A lot of them will just offer a description like the angle of elevation to a kite. And so you need to know where to draw it, right? Like where are you putting the angle in your picture? In terms of this kind of project or problem, what could you measure? And don't think of just hot air balloons. Like think of being out on the tennis courts looking at the top of the light pole. Can you measure the top of the light pole? No? And especially if it got any higher than that, right? But could you measure, what could you measure?
The distance between the pole.
Yeah, like you can control that, right? Like how far away you stand from it. Good? What else? You heard me asking Mr. Pism about a clinometer. So that thing measures what? The angles, yeah. And we can either make them or use the app, but we can measure the angle. And so as long as we have two things with trig, that's enough, right? Think of our trig ratios have 3 different parts that we can plug into. So if we have 2 of them, we can solve for the third. So it's actually faster. Remember all that measuring you had to do before with shadows and mirrors? You can just do a quick ground measurement, a quick angle measurement, and you're done. I mean, calculate, and then you're done. So this is a lot more flexible method. All right, let's go do some examples. Note first, there is no picture. So a big part of this is drawing your own. Raise your hand if you've flown a kite before, just because sometimes kids haven't. You haven't? You haven't? Okay. All right. It's fun. You should. Maybe in the spring we'll pull a kite out. Just for fun. Yeah. All right. So some of these scenarios, if you haven't ever had exposure to it, you might have to say, Mr. Erickson, I kind of don't get the context. Can you help me draw the picture? But I think probably most of them are not like that. So Would you like a minute to write this into your notes? Okay. So because you said yes, I'll go put it in mine as well. I'll leave it there while you write. I'm going to go just copy it into the notes section. So did you just work on the multiple choice?
Yeah, but I'm not done yet. I'll be
Okay.
back like an hour.
Will you? I set your FRQs right there. If you just staple those together so they stay together. You see it?
That's for the unit 3.
Yeah. That way when you're ready to move on, you can just grab those. I'll probably print them out for you.
I'll see you later.
Okay. Yep. All right, so like I said, I just moved this down into the examples. Now, this first step doesn't always apply, but your first step is to draw the picture. It's going to help a ton. The reason I say it doesn't always apply is because sometimes you're given a picture and you don't need to draw it. So we're flying a kite, and you don't have to make it an art picture, but sometimes doing it somewhat in context is helpful. Okay. So he's got his string hooked on and he's flying the kite. That's the only things you could see when you're out there. Do you agree? The kite up in the air and the string going to it. Okay. So obviously we need to kind of turn this more into a geometry sketch. So that would be the second step. You can either do that on your original picture or redraw it as a right triangle. So draw the picture, draw the scenario, whatever you want to say, and then make it a geometry picture. Again, you could just add the details into this one, or you could turn it into a right triangle. You decide. Okay, it says 100 feet of string. Where does that go in the picture? Well, on the string, right? And then, of course, it's our hypotenuse on the right triangle. Okay, and then it says the angle of elevation is 52. Where does that go? So in our triangle, do you agree we could put it here or here? Which one is it? Okay, so if you go look at the definition of angle of elevation, it's looking up from the horizontal, right? So looking up at the kite would put the 52 down here by the dude. Right there. And down here in this corner. Okay, it says how high off the ground is the kite? So maybe let's call that H. And it says how far away from the spot below the kite is the man? Let's call that X. Okay, so now we have a geometry picture from our kite picture. Now, you could have done all that in the kite picture. I'm not saying you have to redraw. So number 2, pick the correct trig ratios. How do we know we can use trig ratios? Even before that. And the reason I'm asking is, like I said, on maybe tomorrow, maybe Monday, we're going to have law of sines, law of cosines that is different. And we want to solve it differently. So how do we know we can use right triangle, or thank you, thanks. How do we know, I just told you, but how do we know we can use trig ratios? Yeah, good job. Maybe on your title, right triangles, okay? Only. Anyway, which one do you want to solve for first? Okay, we're solving for x first. Which ratio relates the knowns with x? Yep. Set up, plug in, and solve. So that's kind of like capturing lots of steps. So x is cosine. So cosine of 52 equals x over 100. So 100 cosine 52 equals x. And so x is cosine of 52. That's like 70 feet or so. 100 cosine 52. So, no, I was a little long. 61.6 feet. 61.6 feet. I labeled it with just the little apostrophe. And I guess that's probably worth saying here. Just out to the side of your work, make sure you remind yourself to label. Okay, let's do H. How high is the kite? Well, we couldn't do a shadow on this. We couldn't do we might be able to do a mirror, but it would be tough, right? But with this is extremely realistic to do. Like, you could totally count how many feet you let out to the kite. That would be easy to do. Maybe on your string, mark every 10 feet and just count how many marks go out, right? That would be so easy to do. And then that angle thing, you guys are going to see, it's super easy. It takes like 5 seconds with the app, and even if we make them homemade with the protractor. So the measuring process for this scenario is totally easy. The mirror and shadow would be probably couldn't do the shadow. Mirror would be a real pain. Because you'd have to try to figure out, like, am I right below the mirror? Or below the kite. And that would be a weird measurement. So this is just better. I'm just going to tell you, it's just better. For the height, this is sine now. Sine of 52 equals h over 100. And get h by itself. 100 sine 52 is 78.8 feet. That's up in the air pretty well. Okay. That's an example. There are going to be lots of different scenarios using this. I'm going to think about maybe having you guys do this like as a project at home. We'll see. Man, where's Mr. Pism? March you down to the office. Yeah. All right, why don't you try one? There you go. I'll give you a little bit on this one. No. How long do we need?
30 minutes.
10. Guys, and I think it's helpful if you just draw the pieces, like cliff. I want a red cliff. Cliff. Okay. Person. Water. He already jumped once. Ship. We're just doing the first one. Okay. Angle of depression. Well, first of all, we need a line of sight. And I think you can draw that in. Like, just plan on drawing line of sight first. Okay. Everybody good on what we've done so far? Okay. Angle of depression is relative to the... In other words, is it here? That's how we want. We kind of want to think of it that way. Like, I'm looking down, and so the angle, we want to think of it as being this way. But where is it actually? It's here. Okay? It's relative to the horizontal, not to the vertical. Here's how you think of it. If you've ever been hiking, do you hike like this?
Yeah, so I don't trip and fall.
Okay. No, not even that though. Like, you're looking straight down, you're gonna fall.
Oh.
Right? No, most people walk with their head up and they're like looking out. Okay? Especially if you're walking up to a cliff, you're not gonna walk at your feet because your next step you'll be off the cliff. You're gonna look out, right? And so think of it that way. Like, approaching a cliff, you're looking out. When you get to the cliff, what do? You look down. Kenzie, having a bad day. Okay? So this is look out and down, not down at your feet and look up. Go try it. This weekend. No. Well. Where does the 380 go? Yeah, so 380 here. This is meters this time. The angle then goes 9 degrees there. Well, I don't see a triangle. I mean, I do, but does everybody see that our triangle is really formed like that? And this is 380. This is 9. And x is the distance to the ship. Yes, do you see that? Yes or no? Okay. If you want to use this triangle, that's also okay. But is this angle 9 at the top left?
No, it's the bottom.
You could put the alternate interior angle right there. Okay? Or you could do the complementary angle. We know that horizontal and vertical are perpendicular. So you could say this is 81 if you want. But you don't have to use that angle up there at the top left. You don't have to. Point is, though, you have to pick one of these two versions of the triangle, and you've got to make sure you get the angles in the right place. Okay? Start there first before you do any trig ratios. Okay? Again, if it helps, you can draw those in, right, into your actual picture, too.
So why did we do this?
This is just all for the first ship. We'll do the second ship
Why
next.
did they give us 2 ships?
Just to have 2 parts to the problem. If she's what? Yeah. If you only get one shot at jumping off this cliff, it's pretty high. Okay. So hopefully you're solving right now. Like, solve for how far away the ship is. I'll give you some time to do that.
Did I do this one?
If you finish, start trying to draw the picture for the second chip. I think you should just add.
Tangent. There you go.
All right, everybody got a distance for the first chip? How far away is that thing? Here's my work. Either of these triangles will do the same thing. 380 is opposite of the known angle, and x is adjacent. Now, I'm not using the 81 because I don't want you to get in the habit of using that vertical one, the one that's against the wall, against the vertical. Use the angles of elevation or depression. So tangent of 9 is opposite over adjacent, so 380 over x, multiply by x, divide by tangent, and you get about 2,500 meters. So 2.5 kilometers out there. Does that seem reasonable? Absolutely, right? Okay, second chip is beyond the first. So here comes that chip. And again, we're measuring with, not with the vertical, but with the horizontal. So now he's looking out there at that farther ship. Do you see how the angle is less with the horizontal? Okay. So that is now 5 degrees. And it wants us to find the distance between the two ships. So I'm going to call that D for distance. How? Can we just repeat the calculation for the second ship and then subtract? Yep. Okay, so do that, please. I'm just going to work on it while you finish up because it's literally the same exact calculation, only change the 9 to a 5. Did you do that?
Yeah.
What'd you get? 0.4? Okay. I'll just leave it as that. 43. Okay. So you should on that one get that it's over 4,000 meters away, which is 4.3 kilometers. Okay. It should have been 24.99. Oh, my fault. 23.99, so about 2,400. Thank you. Thanks. Sorry about that. Okay, distance then. The distance between them, we just subtract. And what do you get there? 44? 1943? Okay. Thank you. All right. Everybody good? All right. Here's another one. Or do you want to start trying your own?
No.
You're still working on it? Getting the hang of it? Draw a good picture. All right, just to make sure you're on the right track, there's your picture. Where does the 55 go in the picture? Right there. And that's only one known in the triangle at this point. So is there a way to get another known? Yeah, like we know the distance between the two tops of the buildings, right? So that is 120 feet. Okay, which ratio is this going to be? Okay, what'd you get? What was it? 84?
Yeah.
And what's the label? Okay, I do want to go back and point out a couple things, so put your pencils down and make sure you catch this. Note the guy, like we have been drawing the guy or the girl, and normally so, standing up off the ground. So that one, same thing here, same thing on our kite problem. Oh, I put that in the notes. Let me go to that one because that one's the most important. So I want you to note, technically, like in our kite problem, technically, our triangle is from his eyes. Do you agree? And it will be too when we go outside. When you're looking through the clinometer, either homemade or app, it's up here at your eye. So if we say this kite is 78 feet off the ground, or 79 really, it's actually a little higher than that because we have to add the height to our eye first, or not first, but at the end. Make sense? So just know, like this problem didn't say anything about the guy's height. If you go back and read it, it kind of makes it sound like he's got the string on the ground. That's how we did the problem. Maybe if you can find this example real fast, go say plus height of I. And I didn't want to bring it in there yet, but now that we've gotten a few reps of this and getting a little more comfortable, we do need to be aware that that will change it sort of, okay? Now, in this case, it changes it. Let's say, like my eye, let's say is 5 feet. It's a little bit more than that. So it's a little bit bigger percentage, like 5 out of 80 is not insignificant. On the ship problem, first of all, your eye is like barely over 1 meter, right? So does that matter in the scheme of 2,400 meters? Not really. Like that's this much difference in 2.5 kilometers. Like that's nothing, right? So in some cases, the height of your eye is not really that big of a deal, but just know that we have to consider it, okay? And usually the way you do that is do the whole calculation and then either add or subtract the height of your eye, okay? And I will tell you that in problems where it wants you to consider that, it will say, Johnny's eye is, or Johnny is 6 feet tall or something like that. Okay? So these ones we've been doing, like the building one just now, it doesn't tell us that. You just kind of have to understand that the analysis is actually like right off of the corner of the building, not at somebody's eyeball. Okay? Everybody, any questions on that? And again, like here it was 84 feet, so 5 or 6 feet out of 84 may not be insignificant depending what you're doing, but it's not like a huge deal. All right, I think that's good at this point. Why don't you give those a shot? I think the hardest problem to draw the picture for on that one is number 9, the airplane. Actually, there's 2 airplane ones. So if you want, you can try drawing those and then I can check them with you so you at least have the correct picture to work from. This one, this is the same
Yeah.
as your number 9?
Yeah.
Okay. Yep, so why don't you try drawing the picture for number 9 and then we'll double check.
It's my airplane. You like it? Directly down the street, there are 2 motorcycles are driving cars. One of their neighbors.
It's a flying potato.
What? You like my airplane? What is that?
All right. You can keep working. What did you say?
Yours actually looks like it has like. Oh, my turn to look at you look like that. Oh.
Okay, something like that. And then you good?
Yeah. Actually, yeah, no.
Okay,
Oh, what happened?
you can solve that. How about number 10? Does that one seem hard? Or are you good? Now the 2 things that airplane's looking down on are just on the same side. Number 10, the picture is very similar to the ship picture. Actually, it's the same idea. What?
I don't know. I was just like
7?
Here's diner.
Okay. TV tower.
Why don't we just do a box? A box.
There's our tower.
I've never seen a box.
Angle of elevation is now looking which way? Up. Now, it doesn't say anything about his height, so just do it from the ground. Okay, so there's one angle of elevation, and then Find the angle of elevation for Ryan, who's farther away. Like that. And then we are told that this is 80 feet, and this is 62 degrees, and the tower is 950 feet. Okay. That one you have to solve for an angle. So remember that's inverse or arc, sine, cosine, or tangent.
Okay, let's play like that. No, don't tell me. They're just gonna read it. It doesn't look like sparks. Doesn't look like sparks. Yeah, like what you have over here.
I'll leave those up for a second if you need them. But you guys, you should practice drawing your own pictures on the other ones, right?
I know how, but like the pictures just don't come out like the pictures.
Yeah.
Like my
Maybe you should sign up for an art class.
No, I'm gonna fail.
You have to take an art class.
Yeah, I know, but like I'd rather do it.
I didn't take art in high school.
Oh,
I'm gonna click on you.
I was in music.
I don't
instead.
understand why
oh,
it's
it's art. It's art. Visual arts.
art.
Shut up.